have a speaker who spent many years as a technology evangelist on a variety of platforms. He's currently the senior database technologist for Altabase. Please welcome Nicholas Porcaro.
Yes, I am here at this fantastic company, Altabase. I actually got my start in hardware. I was a microcontroller programmer doing a lot of assembly code, and then my last semester of college I realized I hated hardware and I wanted to do software. So now through many different jobs and snaking my way up, I got to this brilliant software company. Today's talk, Hybrid Databases, Your Cloud Silver Lining. It was the most clever title I could come up with. So let's get started here. So first I just wanted to start a little bit about talking about data itself. Obviously, that's what we're all here for. All of you have a tremendous amount of experience, I assume, with different types of database management systems. And you all face different types of problems. So I'm going to try to target this talk about one particular problem that I think is a very wide-reaching problem. In the advent of Facebook and social networking and machine-generated data combined with user-generated data, people giving their data away for free at tremendous volumes, has really made this huge explosion in how much data is being stored. Companies like Google and Facebook have found this amazing way to monetize data that was once looked at as really tremendously insignificant, like where a mouse might be on a web page or how many times somebody visits a certain kind of restaurant. That may lead to somebody who's selling a certain type of t-shirt. I don't know what the algorithms are, but they do, and they've made a tremendous amount of money from those types of things. So the problem with a lot of this data is that it has lacked structure. It's not all just username, password type of thing. People are uploading pictures or uploading geo coordinates, things like this. And what that has done is required a separate system to meta tag all of this data and monetize it, because a picture in and of itself is useless. But if you can extract a certain amount of text data from that and process some type of algorithm on it, then that data becomes valuable. So what we're talking about really is the difference between transactional processing and analytical processing. Okay, so the transactional processing part of it is the type of database that relational database management systems are very, very good at, obviously, because they are serialized data, they are data that's machine readable, and there's various optimization techniques that exist out there to make sure that that data comes across very quickly. But what we've seen in the last few years is with this analytical processing, we've seen this need to account for different kinds of data. And each of those individual pieces of data could be orders of magnitude larger. So one single picture might be worth 10,000 users worth of data, just a first name and a last name. So the problem that a lot of industries face is that getting the data from the transactional and the analytical side to play together is quite cumbersome. There's usually a lot of layers that the data has to go through in between those two kinds of systems before it's workable on either end. So if you have a login system that is going to use your transactional performance, you may want to be able to do some type of analysis on that. Let's say where the user has logged in from, the geo coordinates or the IP address of where the user has logged in from, and try to make a model around what this user is doing, where they are, and let's say what they were browsing when they were in a certain region of the country, or what they browse at specific times of day. So again, this type of analysis really does not have any solution on the database backend to be real-time or near real-time. It's generally a lot of separate data stores that this data is held in, and getting it to play with each other, again, is kind of cumbersome. The other problem is that transactional systems really are more programmatic. You can take an application engineer, sit them down in front of a standard SQL database, and they'll understand how to use it relatively quickly. It's not very difficult to understand. It's not a very cerebral education that they need to come up with this type of thing. The problem is to find experts that are good at analysis and good at understanding what kind of data needs to be where, and optimization of that ETL. What data from my transactional system is important for me in my analytical system? What isn't? The reason why that question is important to a lot of companies is because they don't want to spend any time with this ETL. They know that it's a sunk cost, that they're going to have to spend some time. If you could get an expert that is good at this analytical processing, they'll be able to say, all right, I only need X, Y, Z plus 1. And that's the way that we'll cut the corner and get around having to process all the data. So again, there's a major divide in between these two systems right now. Analytical systems are incredibly important. Transactional systems are incredibly important. There is no company, I don't care if you're a hardware company, a software company, if you run a restaurant. You need data from both, you need solutions from both, because your analytical processing is going to help you make decisions about your business. The transactional processing, let's say you own a restaurant, you're just going to be processing gift cards, maintaining balances, tracking what people buy, different things like that. But then you're going to take that data into your analytical system and you're going to say, what kind of promotion should I be running at certain times of the year? So even if you're not thinking of it on that level and you're just a business owner trying to get some answers, these two components and the divide between these two affects you. Because when you try to find a solution to bridge the gap between the two, you often have to use several different kinds of layers of software to do this type of analysis. So, the most major portion is the different skill sets that you need. You can't just take a DBA that's, let's say, an Oracle guy that has 25 years of experience and say, help me bridge this divide. Because, again, traditionally, you're bridging that divide on the application layer. You're creating classes in your applications that are doing the ETL for you, or accessing the data from the different types of systems. Or you're just trusting some company that has a third-party tool that allows you to move the data from one to the other. And the skill sets required for each are generally very specific. They're very specific to those third-party solutions. Or you'll find a guy that said, hey, I developed this ETL tool, but I've been at Citibank for 25 years and I developed it for Citibank. It's not really applicable outside of that one use case and that one business. If you want to try to take it to a different business, you can't. If you want to try to take that experience to a different company, that's great, but it might take you another 3 or 4 years to build something like that. So the reason why I'm here today to talk to you guys is to tell you about Altibase and the new kind of way that Altibase is coming in and thinking about data. And I wanted to try to open you up. I don't know, how many people here have ever worked with an in-memory database management system before? So we got 1, 2, not you guys, 3, 4. So 4 people. So, Altibase got to start as an in-memory database management system, and I'll get into the company history a little bit later. I wanted to do the tech part first so that we can get our palates wet before we get into the boring stuff. So Altibase started as an in-memory only database management system. So the way that we were birthed 20 years ago was solving the problems, the traditional problems of in-memory relational database management systems. And obviously the first question that anybody asks about in-memory DBMSs is, what about volatility? RAM is volatile. What happens when the server shuts off? What happens if something goes wrong inside of the application while it's running? How do I know that my transactions are getting across the right way? So these are the first types of questions that we had to answer. We didn't come out with our hybrid database feature until 2005. And I'll talk about that in a minute. But basically, it's kind of easy to understand why an in-memory relational database management system will be faster. Our architecture was designed in such a way to give you really, really fast transactional performance. We're achieving that, obviously, by using the system RAM bus. Okay? So, in 1999, when the company was founded, and we answered all of these questions and we came out with this product, the performance we were getting was simply that. It was simply out of RAM. But at that time, RAM was still, it wasn't prohibitively expensive, but it was only people that had a lot of money to spend on servers that were using this. So we found that our initial set of customers were people that were doing high-frequency trading, just really high-frequency transactional processing or massive concurrent logon processing. But anyway, so to get back to this, it's very, very fast transactional processing. Your system bus, another question that we get asked a lot is, hey, what about SSDs? SSDs are fast. Can I just use that with my current database management system? Sure, you can. But even the best server-grade SSD is only going to be able to provide you the maximum throughput of about half a gig. Okay? Not only that, in SSDs, it's a well-known fact that there is not planned obsolescence, but there is degradation over time. So if you're running a transactional application, that's actually the worst kind of application that you could run on an SSD, because as you do multiple writes and you write the entire disk, those transistors burn out, they lose their ability to hold a charge, and so your 1 terabyte disk that you paid a premium for might only hold 900 gigs a year from now. So when you're using your RAM bus, I mean, even average server-grade RAM is going to give you a throughput of about 20 gigs per second. So we're talking about a 40 times increase with something that you already have inside of your servers. We also say that we have short and predictable response times. Another question that we get asked a lot is, what about outliers? There has to be some type of way that there has to be some catch. There has to be some time where the system has to do some kind of dump, and that will affect the transactional performance. And that's true. So again, these types of questions were the first questions we had to answer. And what we've done to solve that is we've created a system that's very, very customizable. So we allow you to pick the levels of durability that you want. We allow you to pick, when you do our replication feature, what kind that you want. So let me get into that. I'm sure we're all familiar with ACID compliance. Yeah, we all. So when I say that we do incredibly fast transactional performance, these are 100% ACID compliant transactions. Again, as a company that started by servicing stock exchanges, that data is absolutely crucial. If you have a $100 million trade on the books and you hit enter, you expect that trade to get there. You also expect that if something happens in the pipeline on the way there, that no one is able to act on that transaction, so that that entire transaction will get rolled back. We provide you with that. I don't need to explain what ACID is to you guys, but the more important part of ACID that we really do well is our durability. After we address the volatility, the second question that we always get is, well, if you're utilizing disk, how can you be as fast as RAM? How is that even possible? So we give you, again, a configurable way to do this. So we do transactional logging, which means if you're doing reads from your database, nothing is changing, you don't have to worry about it. You have a data file that is written to disk with all of your data that's in memory. So if you have just a purely read server, you will never lose anything ever because there's no logs that need to be written. But for a lot of the systems that we do, that's not the case. The thing that this is really good at is doing writes in the hundreds of thousands and millions of transactions per second. So we provide you with the ability to configure how many logs you want to write, how often they get written, and how often you want those logs to be aggregated into a checkpoint. And the way that we do this and try to minimize the usage of disk is that we can dump the logs in a number of ways. We can dump the logs by our own process, and you can configure within the process the timing for that. Or you can use the system shared memory. And when you use a system shared memory, what it will do is it will aggregate blocks of space inside of your RAM when the transaction volumes are high. And then when the transaction volumes lull down, it will then flush those logs down to disk and aggregate. So we're able to mitigate the gap of RAM and disk I/O by utilizing a combination of both to allow you to achieve very high transactional performance with still having the reliability and durability of disk. However, most of the people, if not all of the people that use Altibase are using our replication feature. And this is a really beautiful part of our database because it's built right into the same interface. So we have our command line utility called iSQL, right? And that's how you can just run, select whatever, create tables, do whatever administration you need to do. Within that same tool, it's very simple to set up a replication. You just say create replication, you specify the IP address, and you specify what you want to replicate down to the table level. And what that gives you is the ability to be sure that you have durability amongst two servers, almost like a RAID of sorts. It's like a RAID across servers rather than across disks. And again, we bring it back to this configurable way of doing things. So you can do asynchronous replication if you just want to push off the replicates to your backup server and just trust that they get there. Or you can do a synchronous replication where you can issue a commit from your primary server to your standby server, and then you can get a confirmation message back from your standby server to say, yeah, I issued this commit. So in an active standby architecture, you're only taking a very negligible performance hit for that. And again, we always encourage anyone that uses us to use this kind of a scheme because it adds a layer of certainty that you don't really get elsewhere with this type of technology. And we can also do an active-active mode where you could have multiple read and write servers. You could have 2 read and write servers, and there is a conflict resolution inside of that built in. You take about a 10% performance hit, but overall, you're getting up to 180% performance from one. And again, this is a feature that is built into our database. It is not an extra feature. It is not a separate piece of software or hardware. It is simply built right in, very, very easy to use. Another part of that is scalability, right? So we talk about the cloud, and really the cloud to me is just distributed compute or distributed storage, right? So when we use our replication feature, we're able to scale out across unlimited nodes for you to be able to take whatever kind of strategy that you need to as far as backing up your data. We've also taken on a sharding strategy. Is everybody here familiar with sharding, database sharding? Okay. So we have an application that we're using currently to shard, and we can shard up to, I believe it's around 32 nodes. So we're currently running some benchmarks on some really beefy hardware with that. But basically, we're able to take advantage of the compute power of 32 separate nodes at one time. So in that, if you are a company that says, hey, I have 4 terabytes of data, but I don't have the money to buy a 4 terabyte server, what can I do? Well, we can give you this database, and we can give you this feature. And with this feature, you can scale that data across multiple nodes and still achieve that in-memory performance. And obviously, with our vertical scalability, we're very, very good at saturating the CPU. So part of the way that the architecture was designed was to take full advantage of the interaction between the CPU and the RAM. Obviously, whenever we're introducing disk I/O, that's where you're going to experience these outliers, these transactions that are taking an inordinate amount of time. So this part is the secret sauce here. Our marquee product here is Altibase HDB. Okay? So what we had done when we first came out with it is that most of the people were deploying it in in-memory only mode. It's a flexible architecture that allows you to deploy in-memory or on disk or some combination of both. So when we first came out with it, people were using it as an in-memory only database. Okay? But now, what we're seeing is people using this database for what we intended it for. We wanted to provide the world with a database that has incredibly fast transactional performance using the memory table space. But also, we didn't want people to have to sacrifice disk space for that. Especially back in 1999, RAM was still quite expensive and the volume of data was lower, but comparatively, the amount of RAM that you would need to use it back then was only for certain niche type of people. As the price of RAM has gone down over the years, this has become a more prevalent strategy to solve certain issues. But the beautiful thing about it is that you don't need two separate places to store your data. So you can take the platform that you have, that's your transactional platform, you can build it on top of an in-memory table space. And you can rest assured that even if you get tremendous spikes in users, in transactional loads, different things like this, that in-memory database is going to be able to handle it. The way that people are selling in-memory databases now is very strange to me. They're really only talking about really fast speeds. And that's not the only thing that in-memory databases are good at. We always think of it as this one quick serialized stream. But really what we can do is take that line and flatten it out. And we can say, rather than 100,000 transactions per second, we can do 100,000 concurrent logons in 1 second. So again, if you have some type of application like we do for E-Trade, let's say, that most of the people are logging on from 9 a.m. or 9:28 a.m. to 9:31 a.m. You're getting hundreds of thousands of people logging on only at that time. And the rest of the day, it doesn't matter. Well, you don't necessarily need this massive scale-out strategy just for that one small piece of logon boost that you're getting there. What they did was they were able to build on top of the memory table space and service those logons using that. But the beautiful thing about it is you're able to take our move command. And with that move command, you issue a move, and you can flush all of that data in your memory table space into a disk table space. Okay? And what that enables you to do is take your transactional platform and also build an analytical platform on top of that as well. Okay? So now what we're doing is we are bridging this gap in between two, what has so far been called different kinds of data. We're allowing you to take it and put it into one place. Okay? But we don't just give it to you. It sounds like, oh, I probably have to change my code a little. This technology like this seems kind of new. What is the effort that I have to put in to use it? And that's the beautiful thing, and thank you, Eric, and for the trivia questions. So here's the answers to most of them. So we are SQL 1999 compliant. The reason why that's important is because nobody wants to have to hire new people when they implement a new strategy. If you're a CTO, you want to be able to say, what can I do with what I already have? I have this huge talent pool that are relational database admins, and they already know how to use SQL Server or Oracle 11g or whatever it is. And I don't want to have to take those guys and task them up for the next 6 months learning a new kind of database technology, learning a new scripting language, different query language. With us, you don't have to do that. Because we follow this convention, we are taking the talent pool that you already have and simply giving them this massive toolbox in order to build these different types of platforms with the same data target. Okay? And obviously, the data types that we support are going to be everything that you expect. Also, one thing that I actually didn't mention here is the ability to use geospatial data. Okay? So now you can build your transactional platform and your analytical platform with a fully featured database that also provides you the same stuff that you would expect from a Google Maps, let's say. If you're building a platform that needs to gather transactional data, analyze it in real time, and then compare against, let's say, users that are around. We're seeing a lot of these types of mobile applications pop up where it says, hey, this person is very close to you. I actually got a notification on my Facebook app this week that they're coming out with that, saying, hey, do you want us to notify you when your friends are around you? And you can't say no to it. You have to just hit next. So I just did. But
You got no words.
so yeah, because like I don't want my wife to be like, "Where are you?" And then I say, I'm over here. She's like, "Well, the Facebook told me otherwise." But so we support geospatial data as well that allows you to build that platform into that same type of a system. We also don't tell you that you have to be relegated to one kind of programming language. Okay, you have people who are experts in C#. Those same people, yeah, they might be able to use Java and they might be able to understand Java, but they're not Java experts. They're C# experts. You can use them. If you have a Java expert, if you have any flavor of .NET expert, you can use them. We have Perl, we have PHP, a lot of other different things that aren't listed up here. But basically, again, it kind of goes back to this way that we designed, this different way that we thought about databases. We didn't want to just provide one type of way to be the fastest guys out there. We really were trying to say, how can we future-proof a business? So some of this stuff was pre-existing. But one thing that I'm very proud of is, you see up there, the .NET Entity Framework. Okay? So as a transactional database, starting as a transactional database, we did not think a lot about having an object relational driver, okay? Because the additional statement overhead required to use object relational mapping was not something that was really in line with having a very fast transactional database. But a few months ago, we were talking to a client, and they had said that they had a platform that they had a need for this for. And we kind of said, well, why? So they made a case for it, and they said, people that are SMBs, people that don't have lots of money to spend on experts, could use this, because the kids that are coming right out of college that have had experience, there's nobody that's coming out with a DBA degree, for instance. You're coming out with a lot of application programmers that have had some database experience, but it's mostly just been connectivity and simple CRUDs, The thing that these kids understand is object relation. Because that's, using all these object-oriented programming languages, that's the way that they've been taught to think about programming. So we said, hey, you know what? We'll do it. And we came out with a fully featured driver in just a few months. So we pride ourselves on being very engineering heavy and very forward thinking. So that's one thing I wanted to talk about here. And then obviously we are going to be a database that you can connect to with a lot of different communication protocols. We provide more than just TCP/IP because we want to be able to allow you to develop the platform that you choose. So if you say, for this specific application, I only just need to process a lot of data. I don't necessarily care so much about storing it, or I just need to make decisions on it. Maybe you're going to use shared memory, because that'll be a lot faster for you. So we also provide with those types of connection schemes. And this is just a slide talking about, we provide with a lot of different tools. We could import flat files. We provide a tool called Migration Center that allows you to connect to your databases right now and see what's going on in them. It allows you to map certain data to different table spaces. It really helps you in the beginning stages of your planning into getting into the in-memory database world, because we allow you to look at your current data, map it to what we offer, and then map where some of that data will go. So a lot of people, their needs for real time are not very large. It's only a very small subset of data that they're going to be using for that has the real-time needs. And the rest of it is just permanent storage used for analysis. And again, we're not just a Linux shop. Obviously, you're going to get the best performance on Linux, but we do support all the different commodity platforms. And we allow you to work on whatever servers that you already have. So the cloud portion. Why does this matter to you? Okay, so we've partnered up with Amazon. We've talked with them, and we've developed an AMI, which is really just a bootable virtual machine on their platform. And we're currently developing on the open and Docker platforms to allow you to have virtual machines. But the reason why this is important is because we're trying to bring this in-memory technology to people in a way that's very easy to swallow. You know, moving your data to in-memory, especially if you have a good amount, is kind of a very scary thing. So the reason why we're saying that we're the silver lining in your cloud is we're allowing you to kind of dip your toes in the water. If you already have a cloud-connected system, you can spin up an instance of Altibase and just see what kind of performance it gets you. A lot of the cloud providers out there, like Amazon and Rackspace and these guys, they've started to not only offer you the compute and the memory, but they've also offered you dedicated tenancy, is what Amazon calls it. But basically, a guaranteed stream of data from that virtual machine. So whatever technology that they're using, Hyper-V or what have you, to virtualize that instance, they're also guaranteeing you a pipeline. Now, that's, you're only as fast as your slowest component. So if you're doing transactional performance, but you're only using a, 1 gig pipeline, then that's as fast as you're going to be able to go. But a lot of these guys are now starting to offer 10 gigs and up of guaranteed bandwidth. So what we can do for you is we can provide you with a transactional and an analytical platform. But not only that, we provide a tool on the back end to interact with Hadoop. Have you guys ever used Scoop before? Are you guys familiar with the Scoop tool for Hadoop? It's basically an ETL tool. And what it allows you to do is you can have your RAM, which is going to be your smallest resource. You can develop a platform, a transactional platform on that. Then you can have your disk space and develop an analytical platform on that. But if you're working on the petabyte scale and larger, you're going to be able to use Hadoop to transfer data to and from Altibase with a built-in driver that we provide. So now on this same cloud platform, you could have your Hadoop scale and still have your real-time transactional performance without having to use some type of caching solution or having to use some type of middleware. Everything that we've developed here at Altibase was developed in-house. And everything that comes out of our shop is 100% homegrown. So you're getting this ability to, like I said, dip your toes in the water and get started with developing platforms that are going to be the next gen. Or taking the platform that you already have and future-proofing it by giving it performance that is on the scale of 10, 20, 30 times what you're currently using. And then the last little bit of the technology I just wanted to speak about was the little bit of engineering prowess. Okay, so we have our HDB product, but we also have a product called XDB, our Extreme Database, right? And it's basically it's an in-memory only product. But what we've done here is we've said, hey, let's try to strip away some of the traditional database layers and see what people come up with. Now, we are aware that most enterprises have policies that mandate that their database servers and your application servers have to be separate. But that's today, okay? That landscape may change, it may not. But what we provide you here is something kind of innovative in that space. So what we are able to do is we provide different modes of connection. So if you want to use XDB on the same machine that your application is on, we provide you with two different sets of APIs. So direct access mode is allowing you to take your application and completely skip the TCP/IP layer and just transfer data back and forth from the application to the database itself, all residing in memory. But that is still going through your query processor. And as we all know, when your database management system has to process a query and create an execution plan, there is a significant compute cost related to that, as well as executing it itself. So the other type of thing we provide you is what we call direct call interface. Now this is not for inexperienced people. This is for people that have been entrenched in the C language or C++, somebody that knows database internals. But what it provides you is the ability to compile an application by pre-processing your queries. So you can actually write out that query pre-processed and skip the query processor layer entirely. So you can have your application go directly to the storage manager layer of our database. And what happens when you do that is you're getting performance in the scale of millions of transactions per second. So again, we understand that this isn't the perfect fit for enterprises right now, but we never really know what the next big thing is. And this type of technology, being able to provide you the speed that it can, we think is going to hit it off in some area. And then another part of it is the CDP engine. So what this is providing you is the ability to do complex events processing in a very easily understandable way. You can do continuous query processing. So basically, you're able to use standard SQL queries to build a CDP engine. A few months ago, I was at a Gartner event, and the keynote speaker there had said that there was going to be the 3 things that changed the landscape of data over the next few years. It was going to be sensor data, CDP, and in-memory databases. So as far as those 3 things, Altabase has been doing that basically since the year I was born. They've been doing it a while. So the CDP engine is going to help people that are using tremendous volumes of data and they don't necessarily care about storing the data. But again, we're providing you a platform to build a processing engine without having to have a database, without having to have a programmer that understands CDP. You can just pull any database admin off the street that understands standard SQL. They could use this in-memory CDP engine and program for you something like a real-time flaw detection log, or something like oceanography if you have tons of sensors in the ocean and there's a lot of data that you collect from that. And you say, oh, it looks like the waves are going to be choppy, or the temperature is going to be this. We're allowing you to make decisions based on that data without having to store it, and without having to invest a tremendous amount of money and time in human capital to provide a platform like that to your business. I'm going to pause here for a second, so this is the end of the technical portion. So I wanted to know if anybody had some specific questions that I didn't address in the technical portion.
Before we move on to Q&A,
Oh, sorry.
it's working.
You want to?
Before we move on to Q&A, I just want to give a great big round of applause to Nicholas Parra. And I want to remind everybody we are giving away 5 Chromecasts tonight. Where is the bowl?
Where is the bowl?
There.
Does anybody want to win a Chromecast?
I
will tell you this, even Apple hopped on the bandwagon.
Anybody else want to add anything?
If you have an iPhone,
And we
you have
take
the
dollars.
Netflix app, then you
Dollars and fives. We don't have a business card. Dollars and fives. Nobody else? No? Free toy? No?
Keep that passing now. We'll get to that. In the meantime, let's start with the first question of the evening. Yes, right there.
So, are you using RAM and CPU to store data?
Yes, so what we're doing is we have the ability to make table spaces in either RAM or disk. So when you make a RAM table space, you're utilizing what we call a one-path architecture. So what it is when you issue a query to that specific table space, the data is only transferred in between the RAM and the CPU, and that is giving you tremendous throughput and compute ability. Again, we are very, very good at saturating a CPU. What we want to be able to do with your servers is push them to where the Altabase process is using 99%, right? Because now you're getting every last drop of performance out of your servers. And because you're able to process transactions in memory much faster and in much larger quantity, you're able to when you get the performance out of your server, it's going to be many, many multiples higher than what you would be able to get with a traditional relational database system. Yes?
I want to just mention before we take the next question, good questions do get good hats.
Oh, yes. Those hats are really good, too, by the way. They're too small for my head, because I'm very intelligent. My brain's very large. So they don't fit. Yes?
It seems the objective of Altabase is basically to operate in a real-time framework where you basically selectively store the results of your gathering. Is that correct?
Not really, actually. What you're describing is more of a caching solution, right? So a question that we get a lot is, hey, my SQL server has a cache. Why can't I just increase that cache to be 2 gigs? And then now that's all in memory. And there's really important differences in between that. Number one, as I had addressed with you, that's a 2-path architecture. That is a disk database that is accounting for RAM. That's not a RAM database. So there is additional overhead with creating that cache, storing those results, updating those results, whatever have you. There's a tremendous amount of additional overhead. A cache, and build the right kind of cache for the right kind of queries. So you're either doing that manually and looking into your data and saying, what are people searching for, and building it that way, or you're relying on some type of algorithm that is determining that automatically for you. Okay, so what we provide is a memory table space, so that when tables are created inside of that table space, any query that you run on that data is going to behave at those cache speeds. And the third major thing, and this is the most important thing that is a differentiator, cache is only good for reads. So if you have a system that has a lot of simultaneous logins, or if you have a system like Reddit where people are creating throwaway accounts all the time and constantly logging new data into the database, caching is not going to help you for those things.
So my question was more related to the objective of a database is to store and create a data structure which can then be analyzed either real time or in a batch way. And the question is, where does this in-memory capability facilitate the batch traditional usage of
Sure.
databases?
Sure. So I can give you an example of a problem we solved for people who were doing it in batches. It was China Unicom. Was it China Unicom? Basically, they had the system that you described. So they have prepaid over in China is much larger than it is over here, prepaid phones. So they had a system that was built as a batch mode system. It had a data structure. It was a disk resident database. And every few hours, they would run in batch mode and process the balances on their cell phones. So if you were a user that ran out of time, because of their old system, you were able to game the system, so to speak. So if you ran out of time, they wouldn't cut you off until that batch job ran. So you would be able to talk and talk and talk until that batch job ran. Conversely, if you were an honest customer and you made sure to refill your phone, they might cut you off, and then when you add the minutes to your phone, they'll say, okay, they'll be available in 4 hours. So what they did was they took that subsection of their data and they put it on Altibase HDB, and they put that data that they were processing in batches in memory. So now what they were able to do is, instead of billing once every 4 hours, they were able to bill not only down to the minute, but down to the second in real time. So if your balance ran out, your phone shut off. If you called them to load your balance, it was immediately available to you. So that's one example of mitigating that gap. People who have a data structure, who are doing processing in batch mode, and that are able to use this technology to be able to take them to the next level and really answer business questions and solve business problems without having to change infrastructure or program. Is that more what you were asking, or?
Yeah, it still really doesn't address the issue the database itself is a repository of information, which
Right.
remains fixed in terms of its boundaries. And RAM is sort of fuzzy because, you know, you're not using all the RAM all the time. Or what you can, the memory is dynamic, it moves around.
Well, what our process does, the way it works, is that if you create a memory table space and you specify a size for that, the Altabase process will ensure that that size is taken up. So if, like, the default setting, let's say, is 2 gigs. So if you go on our website, you download our trial, you install it, and you just hit enter all the way through, it's going to be a 2 gig process. So even though there's no data inside of that database at all, the process itself is going to reserve 2 gigs of space so that you can use the database in a way that is not like what you described, this fuzzy way. Okay, because it wouldn't be very good if we were relying on the system to do the memory management itself, because we're trusting somebody else with that. We would rather be the experts at in-memory data storage. Unfortunately, that means that you do need to have the RAM available to you in your server at all times. We do support a feature called Auto Extend. And what this feature does is it says start the size at this amount and then grow up to this size. Okay? So if you have a server, you can say, I'm okay with it only taking up this little bit, but I want the process to grow if it needs to. So in that way, it kind of solves that problem, that fuzzy problem that you were describing. And we can certainly, like, I'll be more than happy to talk with you after this in case there's still more questions or confusion about that, because you don't look like I answered your question. I'll chat with you afterwards. Yeah.
Okay, afterwards. By the way, if you want to continue on the pre-allocated space storage issue, he will be here at the end for one-on-one questions for anyone who doesn't get questions live. So don't feel like you're being left out. Yes.
Okay, I have to actually, if I have time. So in an enterprise application environment, you have 2 set of servers, you can say. One is production, one is DR. So does your application, whatever you've created, actually allows you to sync up with your DR as well? And if it does, what if your DR servers and production servers are in 2 different data sets? One is in London and the other one is in Harrow.
Sure. So yes, in short, yes, we do have the ability to do that. Samsung, one of our biggest clients, you guys are familiar with Samsung smart TVs and obviously their cell phones. Specifically with their smart TVs and their cell phone, the App Store and the cell phone, they have their login system for the Samsung App Store and all of this. We're actually the database backend behind that system. And the reason why they went with us is exactly that. They were initially using Oracle Coherence, and Coherence went down for a bunch of hours, and when it came back up, they lost a few percentage points of their data. They implemented our system on Amazon's EC2 platform in 8 different data centers around the world. So what they did that for, obviously, was disaster recovery. So all of those data centers are linked up. I mean, Amazon has really, really beefy connections in between their data centers. So with our built-in replication feature, you are able to replicate to as many servers as you need to for disaster recovery itself. And that was one of the reasons that they went with us.
Okay, the second question, talking about databases nodes, you have like 32 of them. What if I want to introduce my own load balancer to those nodes and put some business rules in that?
So the load balancing is that's a very good question. It's a difficult problem for a lot of databases. Currently, the replication feature you can use in an active mode. If you want to scale out to multiple nodes but use your own load balancing strategy, it would have to be something that is just generally database compatible. So for instance, when I spoke about the sharding, right? The sharding is not something unique to us, right? That's just a strategy that you can use with any database. So a lot of times with people, the types of load balancing strategies that they take is that they will create Samsung 1 database on this node and Samsung 2, and they will use a load balancer to distribute amongst those databases that have the same exact data structure, but different data. So in that type of a case, yes, you can. But we don't have the ability to do that natively, for instance, on the database layer. And again, we're not really different than anyone else. For instance, I know Oracle has RAC, for instance, and I think something like 10% of their customers use RAC. And of those 10%, 10% of those people only use it with 2 nodes. 90% of those people only use it with 2 nodes. So there's only 1% of Oracle's customers that are actually using more than 2 nodes in a strategy that you're talking about. So yeah, if you're using a load balancer that is just kind of a generic load balancer, we have no problem with that.
For example, Juniper, they actually provide this functionality. They're load balancers. So if I need that, I can't use your system.
If you need that and you're going with an application layer solution, it's no problem for us. But we do not provide beyond 2 nodes as far as load balancing is concerned.
Thank you.
Next question?
So just on the hardware level, so let's say for a small business scale, just trying to get the idea. So for the XDB, how much RAM would you say is typical, and would you recommend to have the applications running, or just have only that server for the Alt-based server? So let's say 96 GB, DDR3, UEMC, EEC memory.
Yeah.
Just
This is another question we get all the time, and it's really, the answer is it's entirely up to you, because if you have an application that only requires 10 gigs of data, I'm not going to tell you that you need 20, So with XDB in specifically, that is going to be taking up however much RAM you need, plus a little bit of overhead for your logging. And then anything else that you want to do is entirely up to you. It's another misconception that I don't want is that in-memory databases require lots of memory. Memory is the way that they're fast, but more memory is not something that makes them faster. More memory simply just means that the table space that you can create will be larger. Exactly. Yeah.
Next question?
I question is in your slide talking about the database can create the table on the desk or in the memory. So I have a question. If I first create the table on the desk, but after maybe long time running, is the application accept this table is very frequent and I want to move in the memory. Can you support this?
Yeah, absolutely. So that was the answer to one of the questions earlier, was we have a statement called move. So any table that you create in either table space, the data from those tables can be moved from one to the other. And it's one single command. So you say move this to that, and you let the operation go, and then you're done. So if you determine, it's a very flexible way.
The original data, right? I mean, you will not destroy original data and the tables are
Yeah. No, it doesn't matter when the data was created. It supports bidirectional data movement whenever you would like it to.
So when moving the data, the data is still available online, right? So other
Yes.
people can access it. And was that affect the performance?
Obviously, I mean, we don't solve hardware issues, so the process will take up, whatever it is it needs to take up to do that. So, but generally, those kinds of decisions where you're moving data from one to the other, those are more business decisions. They're not usually a real-time decision where you're like, oh my goodness, I got to move this data. It's generally something to say, you've sat down and you've said, hey, it looks like this data is a lot more important than we initially accounted for. Let's move that data over to memory and see what happens. Or conversely, this data that we've had in memory really hasn't been being hit a lot, so let's move it down to disk. So it's generally, in my opinion, a business decision more. But either way, yeah, I mean, the database will still remain up. You don't have to take it down or restart it to execute that operation, and it will take up, however much time it takes up. It depends on how big the data is. exactly, yeah. So, when we talk about traditional disk resident databases, this is something that companies are very highly accustomed to already. Making these decisions about when to move data, where to move it, is something that people sit in boardrooms and talk about all the time. So what we're doing is providing you a platform that you're able to do that in real time. Again, the thing I like to say is that we provide you with a bigger toolbox. So the people that you're talking to about data, they've already had all these discussions because they're only using this. Now what we're doing is when you have those discussions, you're saying, should I move this to data and should I move this data to RAM and totally forget about it? Because after it's in RAM, you're not going to have any more performance issues.
We're going to take one more question, but before we do, I just want to pass around the bucket for business cards and or anything. Whoever puts their card in here can win one of 5 Google Chromecast. So 5 people in here will have a chance to.
Did everyone get their info in there? Because I got like business
I see him go for business cards.
I don't have business.
Yeah.
Can I throw
You
it
can write on
twice?
anything and we'll put it in here.
Oh, sure.
Yeah. Pass that around and then we'll take we'll take the last question while.
We had
You want a hand up?
no over here. Yeah.
Well, maybe something else. Why do you use optical database or Windows these days?
Right.
So what is the motivation?
Well, again, the company as a private company was founded in '99, but the research on the database management system itself started in 1991. So this was a research project that came out of the South Korean government, actually. And what they did was they sent a lot of money into the top schools in Korea, like the Harvards and the MITs and things. So at that time, they were researching on how to take this existing relational technology and make it way, way better. Again, who could have really predicted back then that Facebook or Instagram was going to be a thing, that these tremendous data stores were going to be a thing? But there was no specific reason. It was just that that's how it started. And the types of problems that we were solving back then were solved by a relational database. They didn't have really the problems back then that we do now of tremendous volumes of document stores or object relational types of things. It was straight up and down relational database management systems that were performing all of these computations. And we said, hey, how do we squeeze as much juice out of this as we can? I mean, look, we're not competing with people like Hadoop or, let's say, a MongoDB. They do a different set of things than we do. What we're doing is we're telling you that you don't have to waste, your entire engineering department experience and hire all these new people that have experience with these types of things. You can get the real-time performance, the analytical performance, the geospatial performance. You can get all of this stuff with a relational database management system and have experts working on it that have tremendous volumes of experience working with these types of systems. So we're keeping your business flowing and we're future-proofing you by allowing you to use the expertise and the talent pool that is out there.
All right, we're going to do the raffle momentarily. Before we do, I just want to give a great big round of applause. Thank you. Now for the drawing.
Where are we doing the drawing?
Who wants you to take this out? All right, now look in the other direction. Pull out it. All right. Read it.
Christian.
Peraza?
Hunter. Thank you very much.
Yay! Very nice. Yes.
The other way. It's the other way.
Giacomo.
Right here.
Right there. Boom. Cheating.
Let me try the other side. We're trying this side. Can you reach in there, grab out of it? No, wait, mix up first. And then you gotta go the other way when you reach in. Don't look straight into it. No, that's cheating. You gotta look the other way.
Straight the other way.
Linda Fu?
Yeah. This side of the room got together.
And mix it up again and reach in.
That doesn't count.
Oh,
No, they don't count. We just
no, did somebody write on
Is there
this?
something in the back?
Oh, no. Somebody probably didn't write on this. Jump. We're going to take her Chromecast from her house now. Giacomo's got...
Yeah, well, you can sing, guys.
Oh, wait. I got Netflix in my bedroom and my bathroom.
Michael Reisel.
Michael
All right, reach in, grab one out. Without looking.
This is the last Chromecast, ladies and gentlemen. Who's it going to be?
Jay, think about right here.
Oh! One side of the room. Round of applause, ladies and gentlemen. Fantastic.
Now, we got a few more hats.
They don't play Netflix, but they do cover your head.
There you go. That's one. Anybody else? Hats?
Nice hat, guys.
Okay. Yes? Anybody else?
Okay, I'll take it.
All right, we also have pens up front, and thank you all for coming. All right.
Thank you, guys.